Good afternoon, everyone, and welcome to the second heat of the 10th Annual University of Manitoba 3MT Competition 2022. Today's heat is being recorded and is being broadcast live on the University of Manitoba's YouTube channel. I would like to start by acknowledging that the University of Manitoba campuses are located on original lands of the Anishinaabe, Cree, Oji-Cree, Dakota, and Dene peoples, and on the homeland of the Métis Nations. We respect the treaties that were made on these territories. We acknowledge the harms and mistakes of the past, and we dedicate ourselves to move forward in partnership with Indigenous communities in a spirit of reconciliation and collaboration. My name is Dr. Todd Duhamel. I'm an Associate Dean of the Faculty of Graduate Studies, and I'll be your MC for the event today. 3MT is a research communication competition that challenges students to consolidate their ideas and research so they can be presented concisely to a non-specialist audience. We believe this competition provides career building opportunities for our students, celebrates and promotes the research done at the University of Manitoba, and connects our student researchers with the community. We are proud to be associated with such an inspiring group of graduates, researchers who are here today to share their work with all of you. I'm certain that you'll come away enthused by the work that's being done by the exceptional students. 72 students submitted video applications to be part of this competition. Their submissions were reviewed by assessors from different faculties at the university, and a final group of 35 were selected for 3 heats. 12 challengers will compete in today's heat. The top 3 from today's heats will each be awarded a $200 prize and will advance to the final competition to be held virtually online April 7th at 7 p.m. And of course, you're all invited to tune in to watch that event. Our judges today are Mr. John Wilms. John is a business executive with over 2 decades of leadership and technology experience spanning a variety of disciplines. Throughout his 18-year career with IBM Canada, John developed experience in IT project management and organizational process improvement while working with clients in the science and technology, healthcare, and logistics sectors. As part of a team focusing on growth opportunities for IBM, John led the emerging technologies portfolio, focusing on the identification and development of innovative solutions. John is on the board of Supply Chain Canada and is a member of the Canadian Transportation Research Forum. He earned his P.Log from the Logistics Institute in 1999. John has taught classes at the Asper School of Business since 2019 and has a BSc Honors from McMaster University, a certificate in environmental assessment from Lakehead University, and an MBA from York University's Schulich School of Business. Our second judge today is Dr. Melanie Glenring. Melanie is the Acting Associate Head of Graduate Studies in the Department of Psychology. Her research examines sarcasm, comprehension, and humor appreciation in children, adults, and people with autism spectrum disorder. This is her 4th year judging 3MT competition, and she's looking forward to learning about your research today to the students. Our third judge is Dr. Royce Coop. Royce is an associate professor in the Faculty of Political Science Studies at the University of Manitoba and the coordinator of the Canadian Studies program at the University of Manitoba. He received a PhD in political science from the University of British Columbia in 2009. So welcome, judges, and thank you for being part of our event today as you choose the finalists who will advance to the final event. Our judges will be assessing our competitors' presentations on the basis of comprehension, engagement, and communication. They have been provided detailed criteria for their evaluations and will take some time to be able to work through their judgments. And I know that judging this competition is quite hard, so good luck to the judges in that. Each competitor will have only a single overhead slide and 3 minutes for their presentation. The timer will begin when the presenter begins speaking. We'll begin with the first of 6 challengers, then take a short 3-minute break, and then finish the competition today with the last 6 challengers. After all of the challengers have completed their presentations, the judges will be allowed 10 minutes to tabulate the results and choose the top 3 challengers that will be moving on to the final 3MT competition at the University of Manitoba. For those of you that are posting on social media today about this event, we welcome you to tag the University of Manitoba Faculty of Graduate Studies at UM Studies on Twitter or at UManitoba on Facebook. So now it's time to start the competition. Our first challenger today is Farinaz Shariat Day for the Department of Biomedical Engineering. Garnaz's thesis title is Scar-Free Wound Healing via Smart Nanocarrier Drug Delivery. Garnaz, please start speaking when you're ready, and the timer will start the countdown. Go ahead.
All of us had wounds on our skin throughout our lives, and we know the basic of wound healing. But let's look deeper today. Wound healing starts with a stop bleeding and continue with asking cells come to injury site to repair the skin. When these cells, let's call them builder cells, arrive at the injury site, they don't waste time to design a structure. They make a messy and random structure and start to settle down on it. When they are fully settled down, another type of cells, let's call them modifier cells, arrive and start to redesign this structure. Because number of these two cells are balanced, the final result will be an oriented structure like our natural skin. But it is not the case in all wounds, especially deep wounds. In deep wounds, because body is more vulnerable, it asks for more and more builder cells, and they make more and more messy structure. Because the number of modifier cells are not high enough, they cannot keep the speed to redesign this structure. And this messy structure remains as a final result that we know it as a scar. If we want to prevent a scar during the wound healing procedure, we should know that it is very time sensitive. It means if we ask for more modifier cells, while not all builder cells are completely settled down on the structure, there is a chance that we make this wound non-healing or chronic wounds. That's why we cannot use different anti-scar drugs. And that's where my project steps in. In my project, I'm designing a smart carrier that can release the drug in exact moment when all builder cells are settled down and we have lack of modifier cells, not sooner or later. But how does it work? I study and I find a unique marker that present in that exact moment. My smart carrier is sensitive to that marker. It searches for it. If it doesn't detect it, it does not release the drug. But if it detects it, it binds to it and then it releases the drug. When drug is released, it affects on some of builder cells and make them modifier cells. Again, we will have a balance between these two types of cells, and modifier cells can redesign this messy structure to an oriented one as we have in our natural skin. It might not be important for us if we have a small scars or wounds, but it is a big deal for burn patients who have more than 40% of their body involved in a scar. A scar not only compromises their health by increasing risk of infection, but also affect their social and financial aspect of life. And this is how I want to give them a scar-free wound healing via a smart drug delivery. Thank you.
So thank you, Farnaz. Next up is our second contender, Chioma Victoria Wachuku, from the Department of Physiology and Pathophysiology. Victoria's thesis is entitled, Electrical Stimulation Improves Walking and Organ Function After Spinal Cord Injury. But how? Go ahead, Victoria, when you're ready.
Physical exercise. Think about what happens when you go hiking or cycling with family or jogging with friends. You naturally begin to sweat. Your heart rate rises and so does your blood pressure. This is your body working to support your movement and activities. Sounds like a healthy relationship, right? But this perfect balance and harmony within your body can get shattered in a few seconds if you sustain a spinal cord injury, and that leads to dramatic consequences. These include a new reality of living with paralysis. And what is more devastating is that the functions of many organs, as shown on the far left of my slide, drastically get altered. In essence, people with spinal cord injury can only rest and digest and lose their ability to fight or flight. Sooner than later, this same individual starts to develop sedentary-related diseases like obesity, respiratory, and heart problems that will eventually kill them, and at much earlier ages. Restoring the functionality of body organs to reasonable levels after spinal cord injury has been a major concern for affected individuals and scientists alike. Interestingly, we have discovered that by passing simple electric currents to the lower part of the spinal cord, People with spinal cord injury can regain their ability to use their legs, stand, and walk. Now, here is the more exciting part. Not only are they able to take steps again, but they show significant improvement in the functioning of these major organs that are supplied by nerves far away from the site of stimulation. How does this magic happen? We don't know, and that is where I come in. My goal is to determine whether there is a connection between the nerve cells for walking and the nerve cells that supply these vital organs that support movement and life overall. Using the mouse model, I will pass electric current to the lower spinal cord to activate the nerve cells that produce walking, and at the same time, look at the activity of those nerve cells higher up in the spinal cord that branch out to different organs. If I can demonstrate how these two groups of nerve cells talk to each other, then we will be able to better activate the organs using more precise forms of stimulation, enabling people with spinal cord injury walk in a new direction towards a healthier lifestyle. Thank you.
Thank you, Victoria. So our third challenger today is Daniel Schrader-Ojo from the Department of Applied Health Sciences. Daniel's thesis title is Examining the Associations Between Different Physical Fitness Phenotypes and Cardiovascular Risk Factors in Older Females. Go ahead, Daniel.
Heart disease is the #1 cause of death in the world. How do we stop it? I've dedicated my research career to answering this question, and it just so happens that the best tool available to prevent heart disease is free and accessible to nearly everyone. And of course, I'm talking about exercise. Now, you have probably all heard that exercising is good for you, but different forms of exercise can lead to completely different adaptations. Think of a marathon runner and a weightlifter, for example. These observable adaptations are called phenotypes. And this made me wonder, what is the best phenotype for a healthy heart? To answer this question, I performed a secondary analysis of data from 1,000 females aged 55 and older from a previous study. I chose to study this population because I wanted to frame this idea in a clinical perspective. Older adults are the population at the most risk for cardiovascular disease, and females specifically are underrepresented in cardiovascular research when compared to males. I divided these participants in 5 different groups according to the phenotypes of aerobic fitness and muscle strength. I used the 6-minute walk test as a measure of aerobic fitness and the hand grip test as a measure of strength. These tests are simple, practical, and can be easily incorporated in a clinical setting. The participants who scored above the 75th percentile in those tests were considered as being fit or strong, and those who scored below the 25th percentile were considered as being unfit or weak. All remaining participants were attributed to the normal group. And what I found was quite interesting. When looking at the Framingham risk score, which is the percentage of risk of developing cardiovascular disease in the next 10 years, the strong and unfit group showed no significant differences compared to the weak and unfit group. However, when you look at the groups who were classified as fit, not only did they have lower risk scores, but there are also no significant differences between the groups classified as fit but weak and fit and strong. Now, the main takeaway from this is not that strength isn't important. It is crucial for many functional outcomes, especially in older adults. But when we talk specifically about cardiovascular disease risk in older females, it looks like the protective effect of aerobic fitness is higher than the one of muscle strength. And knowing this is very important because a large part of the work that doctors do consists in interpreting the phenotypical information of their patients in order to prescribe treatment. Because of this, my work will provide healthcare professionals with the information that they need to help their patients walk away from heart disease. Thank you.
Thank you, Daniel. Up next is Nicole Stoinick from the Department of Indigenous Studies. Her thesis title is Decolonizing Classical Forms of Music and Performance. Go ahead, Nicole.
Hi there. I'm studying 2 completely entirely different things that you probably normally wouldn't think that they go together, but they do. And I'm on the nexus of studying classical music and Indigenous studies and bringing them together in a really new and exciting way. Now, before I begin, when you think of classical music, what comes to your mind? It's probably something of symphonies, of operas, violins, orchestra. And then if you close your eyes and think about the images that come to your mind, what comes up? And probably likely something about grand stages and auditoriums and concert halls. You can think of dresses and formal wear and tie, and really all images of grandeur that can really seem quite intimidating and honestly, maybe even quite elitist. So why are these images of feelings and thoughts that we have of classical music stamped in our minds like this? And maybe consider, are these actually harmful? Now, I'm not suggesting that classical music itself is the issue, but rather the way in which that we have been engaging it. Now, bringing back towards my Indigenous studies and my research, we all know that we are in an era of truth and reconciliation. And together, collectively, as a society, we are learning and unraveling all the harms that have been done to Indigenous peoples. Now, in recognizing this and acknowledging it, then we also need to acknowledge that classical music comes from Eurocentric traditions that have not made comfortable or safe spaces for Indigenous people. Now, what I am doing is I'm combining my skills as a classically trained musician and pianist, as well as an Indigenous scholar, and I am looking at ways of decolonizing classical forms of music and performance. Now, I'm not merely suggesting that my research is just going to figure out ways to insert Indigenous performers into concerts and how we can indigenize those things, but rather it's a dismantling of a system and changing the ways that we do it, the ways we go about it in alignment with Indigenous worldviews, perspectives, culture, and language. So radically changing the way we work, live, and perform in. And in order to do this, what I am doing is looking at classically trained Indigenous musicians, because remember, we are artists and performers and musicians too. And thinking about the way we engage this music, and also Indigenous specific creative works that are being performed here in Winnipeg. Liqueur, Louis Riel's Heart of the North, Namoyet, an opera from Calgary that centers We Are All One, and then also Connor Chi, Navajo pianist, piano compositions. And through these, what I want to do is reimagine a way that we as artists can engage with this music to feel safe, to feel welcome, and to engage you better as a public audience. Really, because when we think about it, we're challenging a Western tradition that at its core has been intended to erase and replace Indigenous knowledges, worldview, songs, and story. I'm so excited to be engaging in this work. Thank you for listening for me today.
Thank you, Nicole. So our next challenger is our fifth today, and it's Mackenzie Wilk from the Department of Biochemistry and Medical Genetics. Her thesis title is Using Genomics to Predict and Prevent Cisplatin-Induced Hearing Loss. Go ahead, Mackenzie.
They say when you lose someone, the first thing you forget about them is their voice, the way they once laughed, spoke, or even sang to you. Now envision that you are a 7-year-old child who is battling cancer with the chemotherapy cisplatin. The drug has helped the cancer to go away, and when you are in pain, your mom sings to comfort you, always telling you each day how much she loves you. Now, one day you wake up to your mom's smiling face and she's saying something, but you can't quite hear it. You start to panic and tears rush down your face. After multiple tests, the doctors tell you that you have cisplatin-induced hearing loss. The comfort of your mom's voice is now gone. The one relief for the pain is now elusive. As we know, adverse drug reactions from chemotherapy are far too common. But what if we had a way to both predict and prevent them using genetic analyses? Well, my research focuses on just this. The genome holds a wealth of information that allows for precision medicine to become a reality. In order to predict this adverse drug reaction, we can develop a polygenic risk score. Some genetic variants are protective in nature, as seen by the green squares, while others are harmful, as seen by the red squares. Most people have an equal amount of both and aren't at risk. However, some patients are more likely to suffer from cisplatin-induced hearing loss, as they are predisposed with more harmful variants. These patients can be intercepted early to have increased testing performed, as well as alternative treatments considered. In order to prevent this adverse drug reaction, we can find potential autoprotectants through drug repurposing analyses. What we do is take gene expression profiles associated with cisplatin-induced hearing loss, as seen by the red bars, and use them as input into a database which outputs small molecules with the complete opposite gene expression profile, as seen by the green bars. These small molecules can be compounds which are already existing drugs that we can use in further experiments to determine if they protect against hearing loss. For a child receiving chemotherapy, they are fighting for their lives. Let's fight to make sure that they never have to lose the solace that comes with hearing a parent say, "I love you." Thank you, everyone.
Thank you, Mackenzie. So up next is challenger number 6, followed by a brief 3-minute break, which will allow our judges to finalize notes and comments that they have on their scorecards for the first 6 applicants. After that break, we'll come back and we'll have the remaining 6 candidates present their information. So our 6th candidate now is Joanna Alpert. She's from the Department of Natural Resources Institute. And Joanna's thesis title is Effects of Unpredictable Noise on the Abundance of Grassland Songbirds. Go ahead, Joanna.
When asked to think of a grassland habitat untouched by humans, what do you imagine? Do you imagine something like this? If I asked you to think of this habitat touched by humans, degraded, lost, and unsuitable for wildlife, what comes to mind? Are your 2 images the same or different? Before I began my research on the impacts of noise on grassland songbirds, I assumed that a habitat like this was perfectly suitable for wildlife to thrive in. But what you don't see, nor do birds see, is the presence of oil and gas extraction noise, both as a chronic companion to the environment and heard in unpredictable patterns. Grassland songbirds use habitat like this for some of their most important life stages, breeding and raising young to ensure the continuation of their own genes. In this grassland ecosystem, I study how songbird abundance patterns are impacted by the presence of noise to make inferences about their populations and habitat use. Songbird abundance is an important measure of habitat quality. When choosing where to settle, establish territory, and raise young, birds select habitat that offers food, shelter, and that aids in communicating information to each other through songs and other vocalizations. But when noise is on a habitat, it has the potential to disrupt these communication strategies and vigilance patterns, which could potentially lead to population decline, especially for grassland songbirds, whose species are already and populations are already at risk due to habitat loss. Additionally, research suggests that birds may be extremely sensitive to unpredictable noise, as it may be more startling, distracting, and disruptive to their normal behaviors in this environment. So by comparing bird abundances in areas of sites with chronic noise and unpredictable noise, and comparing that to sites without any noise, my goal is to add to scientific understanding on how negative these impacts may be in order to add to management and bird conservation efforts for species at risk. So when you look at this, the habitat may look suitable, but the presence of noise may be altering the quality to such a degree to minimize bird abundance, which could have negative impacts on the population. And by understanding how different types of noises may impact birds, for instance, chronic versus unpredictable noise like I'm looking at, the proper recommendations can be made to ensure that the habitat quality is maintained in presence of these types of noises. So now what do you see when you look at this image? Do you see habitat loss? Do you see habitat degradation and our failure to do anything about it? Or do you see potential to make change? Because to me, I see the possibility of doing incredibly important work for species at risk, including grassland songbirds. Thank you.
Thank you, Joanna. So now we'll take a short break to allow the judges to total their scores so far and make notes on their score sheets. This also will allow time for viewers to take a stretch, refill their snacks or beverages, and then we'll return in 3 minutes. This will also give us an opportunity to realize how quickly 3 minutes passes. So we'll start the timer now. Please come back. Okay, welcome back. It's been our 3 minutes. It goes by really quickly. My own research has shown that getting up from your chair and moving is a really important thing for your health. So I hope you use the 3 minutes in that kind of way. So now as we come back, we're going to move into the second half of our heat today. So we'll have competitors number 7 through 12 presenting. I hope the judges had enough time to be able to jot down notes because this is going really well so far today. So challenger number 7 is Sanjana Chauhan from the Department of Pharmacology and Therapeutics. Sanjana's thesis title is Nerve Regeneration in Peripheral Tissue Using Pharmacological Approach. So go ahead, Sanjana.
Hi everyone. I would like to start with a short story that how I landed up pursuing this research. As I recall, back in India, when I was in school, one of the women sales representative selling products told me that her husband's foot was amputated due to diabetes, which makes her the only breadwinner in the family. My first thought was how limbs could be amputated due to a very common disease like diabetes. In diabetes, high glucose leads to the damage to the nerves that occur near the surface of the skin. This can be extremely painful and cause numbness in the hands and feet, which makes the nerve the longest and the numerous. The literature search revealed that diabetes is responsible for 70% of the limb amputations in Canada. It is an extremely serious condition which needs our undivided attention. It is likely that some of you are wondering that's how this nerve damage could play such a dreadful role in diabetes. So what exactly happens is that the healthy neurons start degenerating as a result of high glucose, leading to their improper functioning. As a result, ulcers can develop, causing pain, inflammation, and numbness around the affected area, which leads to the limb amputation or even death. Now imagine if there is something which can potentially restore the degenerative neurons back into the healthy neurons, helping the diabetic patients the ability to use that limb again. You all are familiar with the molecule called as calcium, which is present throughout the human body, and its essential role is to sustain life. In prolonged diabetes, the improper calcium levels disrupt the neuronal function, leading to its degeneration. Calcium supplements have not been shown to improve this condition previously. So targeting the calcium at the cellular levels is the core basis of my research. You all can see in the slide, a monkey is helping to pull down the calcium through the cell. In the same way, I am using drugs that let the required level of calcium to enter the cell to restore the neuronal health condition. In conclusion, these compounds restore the calcium levels in the diabetic neurons, thereby replacing the degenerative neurons with healthy ones for normal limb functioning. Thank you.
Thank you, Sanjana. So our next challenger is Sonia Wilson from the Department of Plant Science. Sonia's thesis title is, Can canola be tolerant to excess moisture stress? So go ahead, Sonia.
Hello, everyone. What you have in front of you is a simple canola plant. You can observe its root system, that it's young, and that has the potential to grow into a plant with the beautiful yellow flowers that you see driving on the highway, filled with seeds and pods that produce canola oil as well as feed for animals. Even the name canola stands for Canadian oil, and it is a very important crop for the 43,000 Canadian farmers that produce it. What you may not know is that in the field, canola experiences a growing number of challenges to its production. These include pests, production efficiency, and more recently, abiotic stresses. We use the term abiotic stress as an umbrella for problems like drought, flooding, cold weather, and many more. The abiotic stress that I have chosen to focus on is flooding, also known as excess moisture, and how canola is able to tolerate it. Excess moisture stress is very prevalent when the canola is at its younger stages in spring, just like the plant you see here in the photo. Excess moisture stress is estimated to cause crop losses of up to 30 to 45%, which is very significant as Canada grows 20 million tons of canola annually. The plant you see in front of you here, though, even though it's unable to move, is not as defenseless as it may appear to be. Plants have innate strategies to cope that are coordinated by hormone signaling and dynamic genes to help a plant survive flooding. Some plants, for example, will prioritize growing very fast to try to access the atmosphere when they are fully submerged. Other plants use a strategy that changes their metabolic functions to use less oxygen and try to outlast the flooding. The key is finding the genes that lead to tolerance of this abiotic stress, which is the main objective of my research. I am working on discovering areas of the already mapped canola genome that are related to flooding tolerance, and those dynamic genes I mentioned that are responsible for a plant such as the one that you see in front of you being able to survive long periods of flooding. After flooding my populations of canola, I did have groups that were able to fully survive and tolerate being submerged for 6+ days, which I believe will lead to exciting results in terms of showing which genes have a role to play in this tolerance. With this foundational knowledge that my research is providing, future work can develop canola varieties that are tolerant to excess moisture, which leads to greater food security in Canada and for its export markets. As the climate increases in its unpredictability, it is of the utmost importance to ensure that our crops such as canola can defend themselves against flooding and other abiotic stresses so that its production is not compromised. Thank you.
Thank you, Sonia. So Challenger 9 is Wei Yang from the Department of Physiology and Pathophysiology. Young's thesis title is New Immuno-Engineered Biomaterials to Prevent Rejection of Transplanted Hearts. So go ahead, Young.
On September 14th, 1967, 53-year-old Louis Washkansky, a grocer and avid sportsman, was readmitted to Groote Schuur Hospital in Cape Town, South Africa. His diagnosis, end-stage heart failure. Prognosis, weeks. Treatment options, none, save for a procedure that had never been performed in human history, a heart transplant. And less than 3 months later, Dr. Christian Barnard, a heart surgeon, and his team had just done just that, the first human-to-human heart transplant in history. The operation was successful, and amidst the media frenzy on the hospital ward, Louis was recorded speaking to his surgeon, his wife, and reporters just 33 hours after his operation. Louis lived for only 18 days after his operation. He died from pneumonia that resulted as a complication from the primitive anti-rejection medications he was receiving at that time. Over the next 3.5 years, another 163 people would receive heart transplants, and 142 of them would die, the majority from rejection or complications from anti-rejection medications. It wouldn't be until the invention of a new class of anti-rejection medications in the early 1980s that outcomes began to improve. However, even today, patients who have heart transplants face ongoing complications from rejection. In particular, a unique and aggressive form of heart disease affects the blood vessels of these transplanted hearts because of chronic and sustained immune cell activation and inflammation. My PhD research looks at new ways to tackle this problem. We're currently developing immuno-engineered nanomaterials that can control or modulate the immune response and to ward off inflammation. In particular, my work focuses on the use of new zero-dimensional quantum dots derived from the transition metal carbide mixing. We have synthesized tantalum carbide mixing quantum dots using a newly developed process. These quantum dots are 2 to 7 nanometers in size, abundant with surface functional groups, interact readily with cells and tissues, and were highly biocompatible. When I tested these quantum dots in the lab, I cultured the treated human endothelial cells with immune cells derived from another individual. These quantum dots were quickly taken up by the endothelial cells and changed their immunologic behavior. After 1 week of culture, I observed that these cells had decreased ability to activate donor-derived immune cells. When we looked inside these cells, we found changes to their gene expression that was highly consistent with decreased activation of foreign immune cells. And finally, when we tested them in a rat model of transplant rejection, we found, similar to what we found in the lab, and an intravenous treatment with quantum dots significantly reduced the rejection of transplanted tissues. So where to from here? This is just the first report on the development and the immunomodulatory activity of these quantum dots. My lab is currently working on continuing development and optimization of these biomaterials in hopes that a treatment can eventually become available for these patients. Thank you very much.
Thank you, Anne. So our next competitor is Zahra Batten from the Department of Microbiology. Zahra's thesis title is crispy-based silencing of Burkholderia essential genes as a biocontaminant strategy. Go ahead.
When we listen to the word micro, what is the first thought that comes into our mind? Perhaps disease, illness, or infection, but it's always a negative thought first. However, what about when we listen to cheese, yogurt, or beer? Your thoughts changed, right? We tend to divide microorganisms into beneficial or pathogenic, but there are those which have both features. That is the case of my organism under study, Burkholderia. These bacteria have been found infecting people with cystic fibrosis, causing a severe decline in lung function, complicating the disease. On the other hand, the same bacteria can have beneficial properties. They can produce different types of antimicrobials, they can produce bioplastic, or they can have the ability to degrade plastic waste. Based on these conflicting properties, a big question as a researcher arises. Can we customize Burkholderia to have beneficial features without the risk of them causing disease? Yes, that is my goal. Specifically, I aim to create a strategy controlling essential functions for growth. And in order to do this, I will use synthetic biology, an approach that designs and engineers DNA to modify living organisms. I will then accelerate or block certain mechanisms to achieve biocontainment. Different biocontainment strategies have been developed through the years. However, organisms somehow overcome these barriers, which creates the need for an innovative approach. I propose a multi-layered system, which means overlapping barriers that these organisms cannot overcome. By manipulating DNA as the first layer of this strategy, I can control essential functions and cellular behavior. These functions can be structural, metabolic, energetic, and more. Nevertheless, not only do I want a safe system to prevent transfer of pathogenic properties from one species to another, but I also want a prolonged survival for these cells to stop replicating and prevent spread into the environment. I can achieve this by providing an additional mechanism to prolong survival. And this will be the second layer. Now that I have explained all the elements, I want you to imagine this cell, which number one, can be fully controlled. Number two, without the risk of causing disease. And number three, with a prolonged survival that can be managed in industrial applications. And why not? Thinking about the future, we could make the cell synthesize many beneficial products. It would be great, wouldn't it? Thank you.
Thank you, Sarah. So our 11th challenger today is Ryan Ha from the Department of Medical Microbiology and Infectious Diseases. Ryan's thesis title is Development of a New Method for Studying Legionella Infections. Go ahead, Ryan.
Research saves lives. Through research, we've been able to come up with treatments and prevention methods to allow us to turn diseases that would otherwise be considered death sentences into diseases that have been manageable, such as influenza and coronavirus. What if I told you that there's an outbreak waiting for us just around the corner? This will be caused by Legionella, a bacterium known to cause severe lung damage and even death. But we are not prepared for this. We lack vaccines, we have limited treatments, and our detection methods are heavily flawed. And while we remain unarmed against this pathogen, Legionella cases are dramatically increasing year after year after year. So you're probably thinking, if Legionella is such an issue, why don't we just study it? Why don't we just come up with a vaccine or a treatment? It is not that simple. While we lack tools to treat Legionella infections in the clinic, we also lack tools to study it within our labs. Our methods fail to recreate the complexity of our lungs. My research aims to address this issue by developing what is called trans-well culture. So what this does is it allows us to recreate this lung structure. What most researchers do when they study infections is they take some cells, they infect it with bacteria or viruses, and then they look at it to see what happens. This fails to recreate the structure of our lungs, the complexity of it. Within our lungs, we have different layers with different cells with different functions, all working together to fight off infections. What the trans-well culture does to address this is it has different compartments with different cells with different functions, mimicking the structure of our lungs. Using this structure, we can develop tools to observe the infection, and then we can see how Legionella infects our lungs and damages them. Once we understand this whole process, we can come up with vaccines, we can come up with treatments, all to fight off infections and protect us from further Legionella infections before they occur. And we've seen just how many avoidable deaths we could have prevented with COVID-19, if only we had acted in time. Using this structure, we can research Legionella and come up with ways to prevent all these deaths before they even occur. So the issue is that, well, while Legionella is not an issue today, we must work hard and act swiftly in order to prevent it from becoming tomorrow's issue. Thank you.
Thank you, Ryan. So our 12th and final challenger in the second heat of the 3MT competition today is Jeff Paul from the Department of Biosystems Engineering. Jeff's thesis title is, "Can nudges help engineering professors be better instructors?" Go ahead, Jeff.
How would you react if I told you you had to go to school for 8 years in order to understand how to do half your job? Unfortunately, that's kind of the case for many professors in engineering, where prior to being hired, they must first demonstrate they've mastered their specialty, usually by attending at least 8 years of school. However, in their future career, only half their job is focused on research in that area. The other half is teaching, and being effective in the classroom requires 2 specific sets of mastery: domain-specific expertise, which they have lots, and pedagogical content knowledge, or how to teach, for which they have minimal, if any, formal training. Thus, after being hired, most professors have to develop the second skill set through more courses, seminars, and learning on the job. My research looks at jumpstarting this process by using nudge theory to trick the professor into using effective pedagogies. So that begs the question, what's a nudge? Essentially, it's an indirect suggestion that encourages the professor to use pedagogies using our understanding of how the brain works. Let's try an example. I want everyone listening to me right now, as quickly as they can, think of a color. I bet a lot of you said red. Well, there's a couple of reasons for this, but I've tricked you slightly by putting a red scale on this slide, and I'm wearing a red shirt. Having said that, you may not have selected red. Nudges are not guarantees. They simply use our understanding of behavioral science and models of how people make decisions, both consciously and subconsciously, to nudge, not guarantee, people make a specific decision. Nudges like this have been used successfully in public health, public policy, and other disciplines, but can we use it to help the engineering professor? My research is currently looking at PowerPoint, which is ubiquitous in the engineering classroom. However, it's often used to simply overwhelm the student with facts. PowerPoint is great at displaying facts. However, learning science tells us that too much new content too fast leads to something called cognitive overload, which impedes learning. So what if we modified the PowerPoint template to subconsciously nudge the professor to reduce the cognitive overload? And because we know that learning is most powerful when connected to practice, could we also modify the template by including a link to a mini lesson on cognitive overload or other teaching hint so that the instructor could learn and apply pedagogical content knowledge in the act of creating the lesson? If my research is successful, I'm going to use nudge theory to put a thumb on this scale and prove improve learning for everyone. Thank you.
Thank you, Jeff. So this completes the Challenger presentations for this afternoon. Thank you to all of you for attending today, and also thank you to our challengers. The presentations were phenomenal. Those were really outstanding presentations on very diverse research topics, and we could see that you were really working to be able to share the information in ways that our community can understand. So a virtual round of applause to you. Okay. I've been influenced. The judges will now meet virtually in a breakout room to total their score sheets and to determine who will be advancing to the 3MT final event. The judges' results will be announced live in just a few minutes, so please don't go anywhere. But while we wait, there will be a short slideshow introducing you to some of the university's past 3MT winners. So please enjoy the video. We'll be back soon, and then the winners of today's heats will be announced in a few minutes. So enjoy the video. Hi, welcome back, everyone. The judges have made their decision, and they wanted to express that this was not an easy task at all, as the challengers were all outstanding and their presentations were very well done. I know when I was a master's or a PhD student, I was not able to talk about my research in these ways. So I also want to add my personal congratulations to everybody for being able to develop such nice 3-minute presentations. Okay, so presenting virtually is a skill that has been made a necessity in the last 2 years, and every challenger should be very proud of their presentations. So the challengers that will be advancing to the finals on April 7th, and they'll each receive a $200 prize. And so I'm going to now announce who the winners are, and there's no particular order to the names that are being presented here. So there is a slide that we'll put up. So Daniel Schrader-Rojo, Weiang Yan, and Ryan Ha are the 3 candidates that are moving on to the April 7th event. So each of them are being highlighted on the screens. Congratulations to the 3 of you. But again, congratulations to all 12 of our challengers today. This is an incredibly high quality event. I'm really glad that everybody participated. So congratulations to the winners that are advancing to the next stage. For everybody else, there is a wildcard selection that will be announced after the final 3MT heat. That 3rd heat is tomorrow. Following that, the wildcards will be selected. So the wildcards are being selected by a committee who will be attending all 3 of the 3MT heats and voting on their choice from all of the competitors from the 3 different heats. The wildcard selections will also advance to the finals, but will not be awarded the $200 for this first round selection. However, the wildcard selections will be notified by email early next week after all 3 heats are completed and the judging is done on that round of entry pathway. It has been a wonderful day of diverse ideas and exciting research today. So thank you to all of the challengers for sharing your research with us. I'd also like to thank our technical team of David and Teddy, who are instrumental in facilitating the live event today. I'm really glad that you made me look as professional as you have. I'd also like to say thank you to the students, their advisors, and their friends and family for the support. I know students put in a lot of preparation work in this behind the scenes. They consult their colleagues. They also talk to their family to be able to see if the presentations are resonating well in a communication style. So thank you to the families that are supporting our students. And then finally, I'd like to thank the panel of terrific judges that we had today. So Mr. John Wilms, Dr. Melanie Glenring, and Dr. Royce Coop. Thank you very much for the work that you've done. Your service is appreciated. So one final reminder that the University of Manitoba 3MT final competition is on April 7th, virtually at 7 p.m. Everyone is welcome to attend. The link will be on the University of Manitoba Faculty of Graduate Studies website at umanitoba.ca/3MT. So thank you all for attending, wherever you might be today. And on behalf of the Faculty of Graduate Studies, have a good afternoon. Thank you.